The previous session stopped a little bit early, so about 10 minutes early. So we're kind of on a break. But if I think we might want to wait until exactly at 2 because you might get some more people shifting around in the next 8 minutes. So I would wait. How many people do we have?
Yeah, we'll wait until the top of the hour to start the presentation.
Thanks, Dave. In a way, I'd say, yeah, go for it. But then there might be 3 or 4 people that come over from the other sessions. You never know.
Yeah. So we'll wait to top of the hour. Thanks for that.
Sure. I'll put up a little slide reminder. But at 2 o'clock, I've gone ahead and started or stopped and started the recording. So you guys can just kick it off at 2. You can take over the desktop sharing and do whatever you need to do.
Will do. Thank you.
Sure. Can you just see the slide that says 2 p.m. Eastern, or do you see these little thumbnails at the bottom?
No, I think you see the 2 p.m. Eastern.
Okay.
Joining the meeting.
Yeah, we see the thumbnails with people's initials on them. Is that what you mean?
No. There's on my view, there's a bank of slides at the bottom, like a next slide and previous slide. But as long as you can just see the 2 p.m. Eastern piece, that works for me. Thank you.
That sounds good. We just need a little music for the next 5 minutes.
I have my 7-year-old's Katy Perry playlist. Okay, I'm gonna go close out this next door meeting.
All right.
Carol and Daniel, you guys there? And can you see my screen okay?
Yeah, liberate your data scientist. We see it.
Okay, we'll start in 1 minute, everybody. Okay, let's get started. So thanks everybody for joining us today. We're gonna show you some from a live demo here and show you just how we can go from raw data to an enhanced data model to some ML, where we're gonna predict some sales back to reporting on that sales. So we're gonna show you a 360-degree from raw data to modeling to data scientists back to the BI community, all within the next session here. So thank you for joining us. I'm Dave Mariani. I'm the Chief Strategy Officer and co-founder of AtScale. What we have with us today in this session is Daniel Gray. Daniel Gray is the VP of Sales Engineering at AtScale. He's going to be representing our data science persona, while I'll be representing the business intelligence persona. We also have John Lynch. John Lynch is a sales engineer at AtScale, and he's been, prior he was at Data Robot, so he's been helping us really develop out our Python library, which you're going to see today in this demonstration. So again, thanks for joining us. What you're going to see today is a demonstration of how the AtScale stack can really sit on top of and virtualize a data warehouse. And we're going to be using Azure Synapse today as our data warehouse. You can also see how we can virtualize the data lake, ADLS in this case, and get access through Databricks or through Spark. And the AtScale governance engine, the AtScale multidimensional engine, it's a virtualization engine as well. What it's going to do is present a universal semantic layer so that it can be consumed by multiple personas in the organization. By BI tools, which I'll show you how we're going to access it with Tableau and Excel today, and of course Power BI also works. And also how we're going to be able to take advantage of that same semantic layer using a Jupyter Notebook. That's where John Lynch and Daniel are going to come into play. And of course, you can build custom applications with this data. So wherever you do, you're going to get the same answer, regardless of how this data is stored or where it's stored. And that semantic or that modeling layer is so important to making that data consumable, not just for the BI analyst, but also for the data scientists. So I'm going to show you how we're going to take just regular old tables and rows and columns, and we're going to present a really nice, usable semantic layer. And we're going to do all that before your eyes. So what you're going to see today is that the AtScale stack is here. There's a lot of different components, which I won't dive into too deeply here. But you're going to see a couple of interfaces here. You're going to see us access data through JDBC and ODBC using Tableau. You're going to see us with a live connection with Excel, consuming data using OLAP and DAX. And then you're also going to see us consuming those models to feed predictions and to build ML models using our Python library. So you're going to see just about every interface except for our REST interface today. So it's really kind of a three-step demo. And I'm going to sort of kick it off here and spend some time on not talking about slides, but actually showing you product and doing some real work here. And so what I'm going to show you here is we're going to start with the data warehouse, which again, we're going to be using Azure Synapse SQL Analytics as our store. I'm going to go ahead and create a semantic model on that. And so we can make that more consumable. And so I'll be playing the role of the data publisher, the semantic modeler in this demo. Then I'm going to hand over the presentation and the screen to Daniel Gray and John Lynch. And what they're going to do is that they're actually going to use a Jupyter notebook to actually create and model new data. And that enhanced data, it's going to be predicted sales, are going to be added back to the warehouse and back to that semantic model automatically. And so from that point on, I'm going to show you also how we can consume. So I'll be playing the role of a data modeler today, and I'll be playing the role of a data consumer using Tableau and Excel. Okay, so that first step. So I'm going to go right now, I'm going to exit out here, and I'm going to go to what we call Design Center, which is AtScale's design environment for authoring this semantic layer. I'm going to create a new cube called AI Fest for today's demonstration. And what I've just entered here is I've just landed on a canvas. So this is what we call the Design Center canvas. So you can see on the right over here, I have dimensions and measures, and there's really nothing there yet. So what I'm going to do is I'm going to go to my data sources, and AtScale is a virtualization platform. So you can see I have a lot of different data sources from all kinds of different warehouses, whether they be physical data warehouses like BigQuery and Snowflake, or on-prem like Teradata, or actually SaaS applications like Marketo and Salesforce. But today I'm going to be looking at my data in my Azure Synapse Analytics SQL data warehouse. And I'm happen to be a digital store. So we're a web-based store. And so what I'm going to do here is I'm going to pull on to my canvas my web sales, and that's what I'm going to start with. So what is this that I just did? Well, you can see that this is actually coming directly from Azure Synapse SQL, and it's a table called web sales. If I double click that, I'll get into my data wrangling view, and I can see exactly what data I'm dealing with. Now I have the ability here of doing and actually implementing transforms directly to these columns of data. You can see I have some data information, and I'll have all my sales information when it comes to the number of orders, the kind of products that were ordered, etc. So the first thing I'm going to do is I'm going to add a calculation. So with AtScale, I can add calculations. I'm going to add a sales tax calculation. And what's cool about this is that I can just actually use Azure Synapse SQL and pass in snippets. In this case, it's a little formula for calculating sales tax. And just by doing that, that's actually going to create a new virtual column in our virtual cube or our model that we're building. So there you see our sales tax, and there's the preview. So now if I go back to my main canvas, what you're going to see is that there's my new virtual column. So I created a new column. That's great. So let's now add that to our model. So the way I do that is I take my sales tax and I add it to my dimensions panel. You can see here I have a nice human readable name. You can also see that we're going to choose an aggregation method. I'm going to leave the default as sum. And you can see I can put it into a folder. So what did I just do? Well, look at my preview. There I have it. I have my first sales metric added to my virtual cube. So let's go ahead and let's keep going. Let's add in order quantity.
Oh, Robbie?
Somebody needs to go on mute if you wouldn't mind. And I'm going to go ahead and add in order quantity and go ahead and add that to I definitely going to want to look at what has been selling and how much, and look at in my sales bucket. So I'll do that with sales amount, and I'll go ahead and put that in the folder as well. Now, what I also want to do is I also want to do a standard deviation of sales, and I'm going to set this up a little bit for Daniel, because I think he might need that. That particular calculation. So I'll go sales amount. This time I'll name it standard dev for deviation. I'm going to choose my aggregation to be a standard deviation calculation, and I'm going to create it so that you can see it like so. So there's my dev, and I'm going to put it into my sales metrics folder. Now, I think Daniel might need one other. I think he might want to look at average sales. So I'll go ahead and also create that metric as well. And this time I'll just name it average. And I'm going to change my aggregation function to average. So now it's going to average it automatically. And that's going to be average. And I'm going to name it that and put it into my sales metrics folder. Okay, so let's see what we got. So there we got some good sales metrics here, and now we just need some dimensions so we can do some reporting by dimensions. So let's definitely do that. So I'm going to go to my library here. What's nice is that we have the concept of in AtScale of conformed dimensions. Super important modeling concept, and it's really the power of the data model. Because I can, for example, reuse a conformed date dimension, for which it may have very complicated logic in terms of, especially when it comes to retail calendars. I can also bring on my customer dimension, and I'm also going to bring on my product dimension. So what have I done here? Well, I brought these onto the canvas, and you can see that there's no dimensions so far because I have to just create a connection with my raw data in my fact to my dimension table. So let's go and let's do that. So let's say, for example, my product key, I'll connect it up to my product dimension. So what just happened? Well, you can see that this product dimension now appears in my virtual cube, and it is inherited the structure or the roll-up or the hierarchy that's been defined in that dimension. So no matter what I do or what virtual cube or what data set I use, I'm always going to be able to have the consistent view of how products roll up from name, category to line. What about my customer dimension? Let's go ahead and connect that up. Now let's look at my customer dimension. Well, you can see that there's a lot more in that customer dimension than just my customer name. You can see I have also a geography roll up and a zip code roll up and all these different kinds of attributes about my customers. That's because this conformed dimension is actually made up of embedded dimensions. So you can see that my customer dimension from my customer table also refers to a geography dimension and a gender dimension. And that geography dimension is also made up of a snowflake kind of a hierarchy. So you can see there, I've actually have a snowflake dimension. Now I got all that for free just by connecting up those objects. And that's really the beauty of it, is that's all I had to do is connect those up to get all that functionality. Now, what about dates? This is always what drove me crazy. I have multiple date keys. I have order dates and I have ship dates. So with role playing, I can just those connections, and now all of a sudden I have an order date hierarchy and ship date hierarchies all come for free. So let's come back to my web sales view here for a second. Again, this is all on top of Synapse. This is all live. And what you can see is I have a product info field, and that product info field has key value pairs. So there's color yellow, there's style U, there's size XL. Well, I'm not going to do any kind of ETL on this. I'm just going to go ahead and click on that field and actually create virtual columns, because AtScale understands nested data, which is obviously a very common style these days. So there's color and then there's style. So now let's go ahead and make those dimensions in my model just by dragging them in to my panel. And now I have color and style as dimensions. No need to create a star schema or doing any of that rigmarole just to get or unnest that data. So I have a pretty good model at this point, and I'm almost ready to go and actually start to model that data in Tableau and Excel. But let's go ahead and do one more thing. So I'm going to actually define what we call a drill through, and I'm going to show you why this is cool and important in a second. Because I may want to look at my customer details, And my customer details, you could see here on this new virtual cube, I might not have obviously my customer name. I may want to have their country, their state, and their city. I may also want to have their zip code, for example. And then I also want to maybe be able to report at the customer level their order quantities and their sales amounts. So by creating that drill through view, that's going to like make it really easy for me to do some interesting things in my BI tools. Okay, so let's go and let's make this thing real. So AI Fest is going to be available and consumable to all of my customers, so or all my constituents, I should say. So what I did is I just published that virtual cube. All I did was to take what is essentially an XML document and then publish that or let our server know to start listening for queries to come against that particular virtual cube. So I'm going to start, like I mentioned, with Tableau. So I'm now going to fire up my Tableau desktop, and I'm going to connect to my AtScale virtual cube, and I'm going to do a few queries, and then I'm going to pop into Excel and show you sort of the equivalent. So I'm going to log in. Now this is, of course, I could have logged in with single sign-on and LDAP or Azure LDAP. That's all those integrations are there. We also have delegated authorization, impersonation, so you can be sure that whatever queries are being run in your BI tool are going to be run on Azure Synapse as that user. So let's look at my sales, and let's look at my sales, for example, by my product. So these are now all running live queries against AtScale here. So there's my sales by product. You can see I have a sports store. I can look at, for example, remember I had color as a dimension. You can see that my sales are broken down by all these different colors. You can see that I have some sales that don't have a color. So you can see that, you know, this was a nested field, and that nested field is now been unnested on the fly by running queries directly against my data warehouse, Synapse. So these are all live queries. So let's look at my order dates by year, for example. And there's my order dates by year. Of course, I can go ahead and keep my 2008, and I can drill down from there, just like I can drill down to quarter, etc. So now, what about how does this all look in Excel? So of course, we're doing a live connection here, right? And I'll show you what happened behind the scenes in a second. But what I'm going to do here is I'm actually going to connect to the same virtual cube, but this time I'm going to connect through Excel. And through Excel, I'm going to connect using the built-in analysis services connector. So there's no install or no third-party drivers or anything to install here. All I did is just use what comes with Excel in every copy of Excel. And there I can see my Synapse sales insights, and there is my new virtual cube called AI Fest. So let's go ahead and choose that. And I'm going to start with a pivot chart. Let's do that. So now I'm connected straight, and I'm going to see the same exact metadata that I just saw in Design Center and in Tableau. So now I'm running a query against my sales, and remember I had that color metric, and what you see is what you get. And just to show you, it's the same. If I come back to that color in Tableau, same answer, same query, same results, same security. So then what happened? What happened behind the scenes there? So let's go back to my query, my Design Center, and my query log, and let me show you exactly how this all works. So you can see that I just ran. Here's my AI Fest. My AI Fest virtual cube just started to live its life a few minutes ago. And what I just did is I just ran a query in Excel, and you can see there's my MDX. Now, what we generated against Synapse is this SQL. And if you notice, what we did is that we actually reference an aggregate table. So let's go back there for a second. This is what we call autonomous data engineering. So when I started with AI Fest, you can see that we were just running raw queries against Synapse, and then all of a sudden we started to use aggregates, and that is really where AtScale gets to be really powerful, is because it learns, and you can think of it as like it's creating materialized views like structures. They're just aggregates automatically based on user behavior. So we're going to make your queries super fast, and we're going to make Azure Synapse work just a little less hard. So so let's go and let's do one more query here in Excel before we leave here. So I'm going to go ahead and come back to my existing connections here. And I'm going to go and choose my my finance. Let's do it a pivot table report this time. And let's look at my sales for a second. So let's look at my sales amount here, but let's look at it over time. So I'm going to go to my time dimension, or my order date dimension here, and I'm going to pull that into my rows. So I'm going to look at my data by time. So there we have it. And I'm just going to go ahead and drill down. This is running, of course, live queries against the warehouse that I just created. And you can see that I have data up into Q3. Actually, it's a little bit incomplete data to July. So what I'm going to want to do now is that, Daniel, things are crazy right now with COVID, and all kinds of there's all kinds of disruptions here. And I'm hoping Daniel, as my data scientist, can take into account what's happening with COVID and predict my August sales for me. So Daniel, I'm hoping you can predict my August sales for me. And so I'm now gonna hand control, Daniel, to you.
Actually,
and I want you to
Dave, if you could.
Yep.
If you
Sure.
could stick, if you can flip back to the slides, but I am up for the challenge. So we'll see if we can.
Okay.
If we can predict. Yeah, based on the metrics that you've already defined for me.
All right. So let's go back to our slides.
Quick slides.
Okay.
Thanks. Sorry. So, as we've been working over the past 7 years, obviously we have a lot of customers that are in the BI space. And what we found, talking to these customers, talking to prospects, is that there is basically a set of metrics that the business is defining. And so, as we met with customers and prospects, they wanted the ability for data scientists to be able to consume these same metrics. So kind of think of it as an enterprise metric repository. And what this does is this ensures that you don't have data scientists in a bunch of different notebooks redefining metrics, redefining time hierarchies, redefining dimensionality, writing a bunch of complex SQL, because chances are someone's probably going to write it differently than another person. So this isn't engineering. You're still going to do all the feature engineering, but what you get for free here as a data scientist is you get the metrics that have already been defined by the business, and you can automatically consume those. You can use our Python library, and you don't have to write any SQL at all. And then in addition to that, what if you find a new feature as a data scientist? If you find something interesting, if you're using some type of library and it says, hey, this is a feature that you'd probably want to reuse and have other data scientists use, and chances are the BI team may want to use it too. What about the ability to create features programmatically through the Python library so that those features just show right back up in the model that Dave walked us through earlier? And then in addition to that, kind of the final aspect is, once you have that final prediction, what do you do with it? Right? How do you provide that not only to power users and analytical users, but also to non-technical stakeholders? So if I'm predicting some type of cells, there's probably someone downstream using something like Excel that's going to look at, okay, on day 28, I'm predicting this cell. So as opposed to giving them Python or giving them like a PDF or something, why not give them the ability to model that prediction right back so that you can start to think about getting prescriptive? And so that's what we heard from our community, our customers, our prospects. And so that's what really triggered the innovation for us around the Python library. And that's what I'm going to show you now. I'll just 2 more really quick slides. I promise not to bore you to death, and then I'll jump into the demo. So from a high level, everything that you heard Dave talk about with the universal semantic layer, it's the same thing when we talk about it as an enterprise metric repository. So it's one single place that you can consume these metrics, and it gives you a centralized location to store, search for the different metrics. And you saw the visual interface that Dave went over, but we have APIs. So this information could go into Calibra, where you have like a centralized place to search, for example. You also have granular role-based policies that you can apply in AtScale. So not only can you apply things like row-level security and object-level security, you can also provide rules for, in other words, that certain data scientists or analysts are not allowed to see a metric or a measure that has, or a category that has a social security number, for example, or a credit card number. So you can apply those additional rules directly within the semantic model. And, and then we're also looking at ways to natively integrate with cloud feature stores. And then, of course, the big thing here that we hear over and over again is, hey, what we find is our data scientists are spending a lot of time doing data engineering in their notebooks. And we just, one of our customers recently said they had 20 different data scientists writing facts and dimensions into their notebooks because they were trying to reverse engineer to figure out who was wrong. And so they were doing a lot of complex SQL. With AtScale's Python library, what you'll see in a second, you don't write any SQL. You just basically tell us the measures, dimensions, and hierarchies that you want, and we just go do all that for you. And we generate the data in the background. And like Dave showed you earlier, the autonomous data engineer is going to kick in and make sure that it's performant. And if data lives across multiple platforms, we're automatically going to engineer that data together. And a lot of good stuff that goes with that. So just on the last slide here. So I think this one's pretty important. From a when we talk to data scientists, if you take something away from that community, they're not going to use your product. If you ask them to change how they do data science, they're not going to use your product. And so it's really important to us is that we didn't take anything away. We didn't ask anybody to change. It's very akin to our story on the BI space. Bring the tool that you want to use. You don't have to go out and learn something new. If you're comfortable in Excel, great. Comfortable in Power BI, great. If you're comfortable in Python, great. And you're not going to lose any of your libraries. You can use sklearn, you can use pandas, NumPy, whatever you want to use out there, you can use. And I've got a couple of examples of that. So you don't lose anything, but you get all these other things. And so that's basically the Python library. So Dave, if you will, I'll jump into. All right.
Okay, let me unshare. Stop sharing here, and you got it.
Okay.
Let me see your.
Let me try. Oh, accidentally unshared. So I'm gonna try that one more time. All right. You guys see a nifty Python notebook?
We do.
All right. Excellent. Thanks, Dave. So just a couple things to point out real quick, and I won't bore you to death by going through a long Python notebook. I think we've all suffered through those demos before. So I'm going to go through this pretty quickly. But the point kind of here is that, to consume that semantic model that Dave showed earlier, this is all you have to import. You don't need ODBC. You don't need additional drivers. You don't need to import anything. Literally, we're completely self-contained. And once you include this, you can log into that same project that we showed you a little bit earlier. And then you can start to do things like list the different measures and dimensionality. So, so you can see the different types of measures. And when you think about it from a data scientist perspective, is that the nomenclature is just different here. So in the BI space, it may be a measure, but in data science space, it could be a numeric, or it would be a numeric. When we say dimensionality in the BI space, that's really categories. So who's, what's, when's, and how's. And these are all the different values you have. You don't have to write any SQL to get them. And anything that's exposed in that model that Dave built, you're going to get automatically here. And as we have compound knowledge and people continue to build that model, you just have more and more measures of dimensionality that you can automatically consume. And then it's really easy to actually go out and get data. So you basically just tell us what you want, go fetch that data for you. So typically you'd be writing SQL. And imagine if you had a much different data platforms, you'd be writing a bunch of SQL and bringing a bunch of data together. Here it's really easy. You get that information. You can do all the standard stuff you typically do. This is a pretty straightforward data set. We recently did the M5 challenge on Kaggle, and it's a really interesting data set. And you do some different things here, but this is a pretty straightforward data set. But you can use different tools and interpolate and things like that very easily. But I'm going to do some visualizations. Like I said, I'm not going to bore you with a whole bunch of different visualizations, but kind of the idea here is that, as you're going through and you're trying to understand your data, You may be using like a univariate type of approach to doing it. You may be using multivariate. You may have a library that's actually is telling you, what is the best, what are the best features to use. So it's really up to you. But the key is that the domain expertise that Dave built into the product, he knows the business. You're getting that automatically. So you're getting that compound knowledge. And I'm just kind of flying through here because there is one thing I do want to show you guys. And we'll have this visualization come up. All right, did some time series. So right here, this particular function here is that I've determined that, hey, there's a particular metric that that I think is important. It's a 28-day basically moving average of sales, and that's based basically on some visualizations that I had before. I'm now writing this back into the model, and this is important for two things. Other data scientists can now use this. They don't have to go back and redefine it. They can now use this automatically. When they do list measures next time, this thing's going to pop up. In addition, as Dave, as the BI persona, when he logs back into the model, he'll now see this and he'll now have a new metric that he can use. So it's that feedback loop between groups, and it's also compounding the knowledge that you get between all your different groups. And of course, a little bit of a error there, of course, but it's all good. I think we'll be fine. Live demo, and then again, I start doing some more analysis. And then what I'm going to do is just a really simple linear regression. So this wasn't really about trying to build a special model. If you guys are familiar with, there's a bunch of libraries that are out there today that you can use. So we're not trying to reproduce the wheel in the libraries here. The point is use whatever you want. If you want to use, Azure's Auto ML capability, you can plug it right in. If you had something like a data robot at H2O, you can actually plug that in. But it's doing some general modeling, and I'm actually going to write this model back eventually into the AtScale model, and along with my predictions. And so basically, what I've done is, again, I've consumed the semantic model that we built at the beginning of the demonstration. Dave built at the beginning of the demonstration. I've then used that to do feature engineering. And again, you can do univariate or you can do multivariate, whatever you want to do there. And then ultimately, I found a new measure, which I thought was pretty interesting. And I added that back to the semantic model. And Dave will show you that here in a second. And then I did a simple linear regression, and I actually wrote that data and that model back to basically a new model in AtScale. So basically what we did is we used inference to understand the prediction and the data types associated with that prediction, and we automatically wrote a model back. So now we can start to visualize that particular prediction. So with that, I will turn it back over to Dave here and stop sharing. All right, Dave.
Okay, so let's go and maybe share back again. And let's see what the heck you did. Okay, so so Daniel, where did you put that data?
That would be in the calculated measures.
Okay, so got calculated measures in my AI Fest. Okay, so well, let's go. You actually wrote the sale. Did you write the sales output?
Yeah.
The prediction.
Yeah,
did you already
yeah.
run the prediction? Okay. So
Yeah.
let's take a look at the prediction here. So let's see. What you called it? Oh, is this what you called it? Which is spelled wrong?
Yeah, it's a web sales prediction.
All right. So so this shows you it's a live demo, right? So I'm going to pull that onto the canvas. So what did Daniel actually do here? Well, let's go and look at this data. So he created me a sales amount. There's a predicted sales amount that came from his model. He wrote it as a table back to Synapse. So that's our interface here. And then he's got actually a date field for each of the predictions. So he has, it looks like it's by day. So then what do I need to do? Well, I just need to then relate that back to my date dimension here. And actually, if I go ahead and try to do that here, you can see that it's giving me a sort of red box around it. Well, it's because, if I do drop that, you can see I'm going to do a date to a long. So it looks like my key for my date dimension is a number or is a long. And so I'm just going to go ahead and write a little transformation. So this happens all the time, right? It's like, but I can do that all virtually in this model. So I'll go back to my web sales, and I'm actually going to go ahead and calculate a new column, and I'm going to call it the order date key. And I'm going to use a simple conversion function in Synapse, and I'm going to convert from my date into a syntax. I'll see that in a second here. There we go. That's just a long. So there's my date key now. So now that I have my date key here, now all I need to do is I can see there it is in my data set, and I just need to go ahead and then connect it up to here. And you can see now I'm going to do an int to a long. That's okay. And I'm going to call it order because it's an order date. And I'm going to go ahead and create that relationship here. So now what I've done is I created a relationship. So now that's all I need to do. What's one more step, which is, obviously I want to make that sales amount now a predicted sales amount. So I'm going to call it predicted, like so. And I'm also going to put it into my sales metrics folder. Okay, so now what do I got? So now I got my sales and I got my my predicted sales. So there you see it, in addition to my sales that were my actual sales. So all I need to do is to make this available here is to again publish that. Publishing it means take the model I was just working on and make it deploy it, make it available to everybody. So let's go back to my Excel environment for a second here. So here I got my my data here, and you can see I have data in July, and it's for my sales amount. And you can see that there's my sales metrics. I haven't refreshed this yet, so you don't see my predicted sales. So let's just go and do a refresh all and see what happens. Of course, this is a live demo, so who knows what's going to happen here. But if everything works right, what I'm going to be able to see here is it's going to refresh not just my data, but it's also going to refresh my metadata. And you can see here, it actually collapsed that because look at that. There's my predicted sales. That's the brand new metric that I just added in AtScale Design Center. And so now what I can do is I went ahead and clicked that and added that to my or my my spreadsheet here. And now you can see that I just added my predicted sales, and Daniel did what he said he was going to do in his Jupyter notebook. He predicted sales for August. And there they are. So so what I just see here, right? We just saw a full turn. You saw a data scientist, Daniel, and a BI analyst like myself, all able to collaborate using one semantic model without having to create data extracts or do any kind of sneaker net to move that data around. So I can tell Daniel, you know what? Hey, Daniel, August is looking good. Can you please go ahead and generate it for the rest of can you generate it for Q4 for the holiday season? And all I would need to do is just refresh this workbook, and voila, I'm going to have all my data there. And this is because we're not dealing with aggregated data here. It means that we're not losing any kind of granularity. We have everything we need here. So that's the other part that makes it great, is that I can always do a drill through or do anything that I would like to get to the raw data if I so choose to. So so let's just come back to my presentation here and see what we got. Well, actually, before we do that, let's go and see what just happened here. So let's go back to our query screen again. And you can see that here's my queries I just ran. And you can see that this was my measure that actually came from my new predicted measure. And you can see that it still is using aggregates. So that's really pretty incredible. And you can see if I look back in time here, I believe these were all the notebook calls that Daniel was running. And so you can see these cubes here, and you see these queries here that Daniel generated. when he was actually working on his Jupyter notebook. It looks like he was looking for, that was the raw data he took just to get out all the metrics that he needed out of my virtual cube. So, so that's really, that's really what it all comes down to, is, we're talking about a full reround trip here. Yeah.
Hey Dave, can you go back to that last query that you showed?
Yeah.
Real quick.
You bet.
Yeah. One thing that may be interesting is if you scroll down and look at the outbound query.
Mm-hmm.
So that's the query that a data scientist would have to write.
Oh my God! Look at that. It's still going. I mean, that's really, when you look at and when you look at just the complexity, and look at that. It also, by the way, we also automatically used an aggregate. If I click on that, that aggregate was 158 rows. So we did all that work to get 158 rows. And, that poor data scientist, if he had to actually write that query, obviously he or she is not going to be happy. So thanks, Daniel, for pointing that out. Is that automation, that ease of use, can't be understated. So so I know we ended up a little bit early here because things went too well, but really open to any kind of questions that the audience may have. I'm not sure if I know how to do that. But if you guys anybody want to come off mute, open to any kind of questions you like to ask, either Daniel or myself. Alex, do you want to say something? We can. Alex.
Hi,
Alex. Hi. How you doing?
great. I do have a question about this very awesome tool. By the way, I've been one of the data scientists who had to construct a cube by hand. So it's very exciting to see a tool that can do this. Because I'm in the implementation, sometimes I want to take the queries and just experiment with them. Is this platform allow me to also experiment with those generated cube queries?
Daniel, you want to take that one?
Yeah. So I mean, there's nothing to prevent you from running those queries. So that query, that outbound query that you saw that Dave showed, there's nothing to prevent you from running that in any type of tool. And sometimes I'll actually do that just to mess with the data. So you can certainly do that. But in addition, if you do the modeling that Dave talked about earlier, you can get to know the data there too. So a lot of times when you're trying to understand the data, you're trying to understand the characteristics of the data, you can also do that through the modeling interface. And by doing that there, when you actually go to consume it, it's simplified. But yeah, you can absolutely run those queries in any type of tool and just investigate the data, and including you could run it through Python too.
Yeah, Alex, thanks for that question. Let me just let me just reshare my screen for a second. What I'm showing you here is this is just DB Visualizer. This is the tool that I like to use, and you can see here that what in DB Visualizer, I'm actually can connect straight to the AtScale service, the AtScale server, and if I do that, you can see that our taxonomy is that you can see that the schema is Sales Insight Synapse. And then you can see that the tables are actually the virtual cubes. So there's our AI Fest virtual cube. And so this is what it appears if you're just accessing it through JDBC. That's my virtual cube. And so you mentioned, can I run queries? Well, let's just go ahead and let's take, and snip out one of those queries that we just ran. Let's see, that was MDX. Let's do a SQL one, since I'm running in SQL. Those are all MDX. Let's see. Yeah, well, let's just take this one, for example. And let's go ahead and run that in DB Visualizer. And what I'm going to get back is exactly the data that Excel got back, or Daniel got back in his Jupyter notebook. There's the data right there. So you know, it's a very powerful, it's very powerful in that this semantics, all the complications that in terms of how these things were related in the data modeling is all really abstracted away. And as a data scientist or as a BI analyst, I could just get the data that I need. I don't have to care about how it got there. So that's a great question. Thank you for that. Any other questions in the audience?
None that I see.
Hi, there we have a question. Okay, so I guess that's it, and I thank you for everybody for joining us today. I hope you had it was informative for you. Look, if you want to learn more, it's AtScale.com. Dave and Daniel are here to help, as well as John Lynch. If you have any other questions you want to follow up with, I'm Dave at AtScale.com. So thanks a lot for joining us today, and I hope you have a great rest of your day and a great weekend.
Hey, thanks, Dave.
Thank
I
you.
appreciate it. Thanks, Carol. And thanks everybody for attending. We put links from the organizers LinkedIn. We put links to the speakers LinkedIn, and we put links to the event link where you can go and download the slides. You can go into our YouTube channel and check out this presentation and others. So again, you guys, Dave, Carol, everybody have a good weekend. I know I'm going to, and you can go off and do your thing. Thank you very much. I'll hit stop on the board.
Thank you, everybody. Take care.
Thank you.